I don't really even know what a TED Talk is, other than I don't see TED anywhere. So I think we're going to just talk about automation in the laboratory. So that's a great topic. And so much. So, what are the areas and why do we need to automate in the laboratory? All of you who work in laboratories or are intimately involved in IVF understand the shortages that we have from a staffing perspective, and then even taking the time to train people. So anything that we could do to automate IVF procedures, whether it's dish preparation, ICSI, and things like that, would really be amazing. And so we're seeing a lot of automation going on. And so what I wanted to break it down into is where are the biggest potentials for automation, and then where is automation occurring. So right now, probably some of the biggest potentials for automation would be in the cryopreservation of oocytes and embryos, because these tend to be microfluidic systems. And the way microfluidic systems work is they're introducing the cryoprotectant in a much more gradual method. So in theory, cryopreservation, we know that this is starting to work. We've seen some of the automated machinery that's being used to introduce the cryoprotectants, as well as to remove the cryoprotectants. The one step that has not been automated, though, is actually placing the embryo on the device. But like, for example, Overture Life, which I have no commercial interest with or anything with, I've seen their system, and it's basically a microfluidic system, so that gradually over time you get an increase in the cryoprotectants. So the eggs and embryos react very differently, because it's not nearly the osmotic shock that we see when we introduce them in a static system. So the potential for automation of cryopreservation and thawing may actually increase. Thus, so far in the automation process, the cryoprotectants can be introduced and removed by automation. However, we still need to place the oocytes or embryos on the device and plunge those. And at the same time, we also have to thaw the embryo ourselves and then remove it from that device. So I think we'll see automation of freezing very, very soon. I know that there's ongoing trials for example, in Argentina and other countries in Latin America. We have ongoing trials. Another area that's very big in automation that I think we could do is dish prep. And this is a lot of technology that we can borrow from the tissue culture industry. Right now, there's a lot of automation of tissue culture dishes being prepped, flasks being rinsed out, and things like that with devices. So we know, for example, that Alejandro Chavez and Jacques Cohen's group are working on automation of dish prep. The challenge that we're facing in dish prep is that right now in our IVF industry, we don't really have a standard IVF dish. Unlike in the tissue culture world, we have a 75 millimeter tissue culture flask, 150 millimeter tissue culture flask, and so on. So the devices that we culture cells has been very well established. However, dish preparation is something that hasn't been. If you'll see a plethora of dishes. So the struggles that we face is not so much automating dish preparation for embryo culture and egg culture, but it's rather trying to settle on a format that we as an industry could settle on. And then also all the companies that have invested millions of dollars in preparing different dishes, you would basically have to come up with an automated system for that. The other challenge that we face with dish preparation is the toxicity of some of the materials that are used. Cell culture preps are much more robust and can deal with tissue culture or with materials that may be slightly toxic, because these materials are diluted out. When we grow cells, we grow them in at least 25 all the way to 150 mLs. When we're culturing embryos, we're only using about 20 to 40 microliters. So the tubing and whatnot that we use has to be extremely non-pyrogenic, has to be non-toxic. And so those devices need to be as well. That's the one. So challenge number one is dish conformation. Challenge number two is using materials that are non-embryotoxic. And then the third challenge is having, you know, the small amount of media delivered in an accurate phase. And this can be done. The other The other challenges that I've seen from automation of dish preparation is the oil overlay versus oil underlay. This again would require changes in how IVF clinics do, because some labs actually put the oil first and then place the microdrop. Other laboratories place the microdrop first and then the oil. So we'd have to standardize that aspect. Well, we've seen the recent evidence of ICSI that was done in an automated state. I think things like hyaluronidasing will require some time. We know that ICSI can be automated because we've seen that done. The Overture Life Group recently had announced a birth of a child that was as a result of automated ICSI. However, in that aspect, we're still having to move the eggs and embryos into various dishes for manipulation. So I think we'll see ICSI probably the first level of micromanipulation that would be automated, but it will be a hybrid for quite some time. The challenges that are being faced is that the amount of gametes that we move in laboratories is pretty phenomenal. So I think embryologists will always serve as the intermediate in these tasks where you will have some automation. For example, when we're talking about freezing, for example, that person will move those eggs into the device and then we'll freeze them later, but the device will perform the freezing aspect. And I think we'll see that theme as well with ICSI, embryo biopsy, and things like that. So embryos will move like that. Other areas where automation is occurring is kind of the combination of culturing embryos now in time-lapse systems where that data is collected. It's automatically moved into electronic medical records, and then the EMR does communications for you. And that is a beautiful thing, because for once now we're taking the incubator, which is the heart and soul of our laboratory, and now that incubator is collecting all this data. It works seamlessly with our EMR, and then the EMRs are automating how we communicate with patients. So we're seeing that currently. There's several companies out there that provide this software that can do this in the interface. So we are seeing the automation of instrumentation from a data perspective being sent out. So really, you know, I think we're at a point now where in several years from now, we'll see that many aspects of IVF is automated. However, the intermediate aspects of moving eggs from dish 1 to dish 2, I just don't see in how in the near future, at least while I'm around, that part would be automated. So without any ado, that was really all on my end, and I want to thank you all for your time. And